Hello and welcome to day one of learning ML with Python from chatgpt. So let's get started. So previously I've started to learn a bit about ML. So I've covered like the basics like KNN, linear regression, logistic regression, gradient descent. So this is like some example of the one that I followed from YouTube. So I did KNN, SVM, I also did neural net. I also went and trained my own neural net to predict whether the last character of a word was an S or not, where I used a Python program, first of all, to convert each letter in the word into like the ASCII value of it, so ORD, using the ORD Python function. Then I wrote it to a CSV file. And then I used it. I can't find it where it is on my collab, but I can show you what I've done here. This here is the code that I followed from. It was Machine Learning for Everybody by Free Code Camp, I think. So yeah, and I also did part of this course, which includes linear regression and logistic regression, with all the loss functions, and this was using it didn't delve into much of the code, it just delved into a lot of the concepts. So today I'll be starting the ChatGPT's start it tutoring me. So you are now my ML tutor. You must create a machine learning curriculum over the course of 30 days in order to teach me from the beginner concepts all the way up to the really ML. I'll do ML/deep learning. Learning concept all up to really advanced topics. Please use libraries like like TensorFlow or PyTorch or Keras in order to teach me this. I don't want to be implementing the algorithms from scratch if they're already available in another library. So the language that I will be using is Python. The structure of the lessons should be like explanation of concept, code examples, then some assignments and or questions. Please make sure that the explanations are very simple. Okay. Please now show me the curriculum. I'll ask it to do first lesson soon. I think that's a good prompt, just to like tell it what it's doing. So supervised versus unsupervised. I'll just see how much of this I know. So what is supervised learning is you already have a bunch of data and it's all labeled. So I can't remember the exact grades. So you have lots of So say in a pandas data frame, you have like lots of different columns. Then the final column is like the one you want to know. So you have a bunch of data. So you have the training, validation, and testing data. You split it up, and like you already got data that you can train on. So unsupervised is it just like learns. Basically, like you don't need to label it for it. It just learns by itself. So simple linear regression using scikit-learn. Okay, so linear regressions just take the basically line of best fit. Then logistic regression, all you're doing is you're moving the line of best fit by a certain value. Can't remember the name of this value. Anyway, as we carry on, but you need to have, those are called hyperparameters that you pass in, like the epoch, the what else is there? Epoch, the amount that it changes, and I think that's the delta or something. So some simple linear regression, small data set. Hopefully it will give us the data sets. That's the thing. Yeah. Data cleaning, normalization, one hot encoding, train test split. Okay, I don't know much about that. One hot encoding. I definitely heard of that. Pre-processing data using pandas and scikit-learn. Pre-process the data set and prepare it for training. Okay. So TensorFlow, linear regression with deep learning frameworks. Implementing linear regression using TensorFlow and PyTorch. Okay. Oh yeah, I've used the. Oh no, I haven't. Used MS. Anyway, introduction to classification and logistic regression. Okay, so logistic regression, accuracy, precision. Not heard of that. Neural networks. Let's go. So I really like neural networks. That's what I trained the model on that predicted whether the last letter was S or not. That model had 87% accuracy, which may seem alright, but it's not actually that good because say the model just picked false for every time, it would have a better percentage of like better percentage of how many times it gets correct if it did false all the time, because 25 divided by 26 is greater than 87, I think. So that's neural networks. So then week 2, training neural networks, backpropagation, loss functions, and optimizers. I've been taught about backpropagation, can't remember exactly. Loss functions, like, that's basically just telling a neural network that you're punishing it for bad results and you're rewarding it for good. Like, there are several loss functions. There's like absolute error, there's absolute mean squared error. Like the squared like punishes really bad like outliers. So it can be good, it can be bad, and the mean is just like an average. And then there's just squared and the absolute. So introduction to deep neural networks, and there's not a linearity. Overfitting, underfitting, L1, L2 regularization. I learnt about this in this course. I cannot remember much about it. It was like a week ago or something. CNNs, haven't heard of them. Recurring neural networks. No. Natural language processing that's going to be quite an interesting lesson, day 14. Generative models. Ooh. Versus discriminative. Oh. Okay. Create synthetic images using a generative model. GAN rather. Don't know much. Reinforcement learning. It's reinforced. There's this one algorithm called what's it called? Minimax, which is very commonly used in tic-tac-toe. I think it's also used in chess, but there are certain optimizations that have to be put onto it, because like there are trillions, I think, of different combinations of a chess one. So Minimax works by going through each possible combination, and like you have like so you're trying to minimize the opposition score and trying to maximize your own score, and you basically it's recursion basically, and then I'll leave that until we get to it. So look for hyperparameter tuning, model deployment, scaling among models, BERT and GPT. Oh, advanced computer vision, final project 1 and final project 2. So I'm just going to copy this real quick to make sure. Make sure like it doesn't forget, and then I'll copy it every time and I'll paste it in. So let me just create a new notepad. I'll just paste this in. Okay. Let's do day 1. And I may do like a couple lessons in a day, because yeah, I quite like this topic. So please now give me day 1's lesson. And I'll just paste it in here to make sure it doesn't forget. Because on my previous lessons, I have just asked it to do it and it just forgets. Like, its memory, like, it's not great on this, so it just goes up with random ones. Okay, so overview of machine learning. What is machine learning? Machine learning is a subset of artificial intelligence that allows computers to learn from data and make decisions or predictions without being explicitly programmed for specific tasks. So there's supervised learning and unsupervised learning. And there's reinforcement learning. So the model is trained on a labeled dataset, meaning each training example is paired with an output label. The model learns to predict the output from the input data. So this basically is that, like, you have a bunch of data, and then it can infer from all that data, like, what a certain data point would be that's not actually in that data set. Unsupervised learning is where the model is trained without actual labeled responses. It tries to learn the structure all patterns in the data. Reinforcement learning, models learn by interacting with an environment, receiving feedback through rewards or penalties based on the action it takes. So this is where I think the Minimax algorithm is reinforcement learning. Because it receives rewards for winning. Like, if, like, say X was at AI, if it won, it would get a 1 score. But if it lost, it would get -1 score. If it was a draw, it would just get 0. So it's been rewarded and has penalties. And it interacts because, like, it just recurses through every possible one and it, like, sets the board as it's going through. So it's supervised versus unsupervised learning. Supervised learning, so input label data like images with cat dog output. Model can predict labels for new and unseen data. Examples: classification, regression. Okay, so unsupervised learning, so we have unlabeled data, collection of images without labels. So output a model that can identify patterns or group data into clusters. Example: clustering and dimensionality reduction. Okay, I know what clustering is, but not dimensionality reduction. So 3, machine learning workflow. So step 1, data collection, gathering all the data you need for training. Like, for a very good model, you normally, well, it depends how many options there are. For really good, if you want to make your model really good, well, you've got to choose the right model for the data set, and you've also got to have a lot of data. Because if you have a very small amount of data, there could be some, like, outliers that, like, just like, say in linear regression, you only had 2 pieces of data. Then they both could be outliers, and they could maybe, if, like, say this is the graph here, and then one is plotted there, one's plotted there. So it goes like that, the line. The model would find that. But what if they're both outliers? Maybe that the gradient is negative, so it would actually be like that. And yeah, there would be quite a few problems that would arise. So data processing, cleaning and preparing the data for modeling. So handling, receiving values, normalization. Okay. Model selection. Choosing the appropriate ML model based on the problem type, e.g. regression, classification. So training. Feeding the model with data to learn from it. Evaluation. Assessing the model's performance using metrics like accuracy, precision, and recall. Prediction. Using the trained model to make predictions on new, unseen data. And deployment. Integrating the model into an application or service for practical use. So it's basically the main steps here are training on like the data that you get from these parts. So you train, then you evaluate, you predict, then deploy. Okay, so code examples with linear regression using scikit-learn. Linear regression is one of the simplest and most fundamental algorithms in ML. It models the relationship between a dependent variable, target, and one or more independent variables. Features. Yeah, that was it. Right, so it's basically you have a big table full of features, and then also one thing you want to do in one of the leading up steps is like the processing of the data. Like you want to take out like features that have no correlation with anything about the what's the name of it? About the target value. Because I was working through one of the YouTube tutorials I was watching, there was this taxi data set, and it was like the amount of miles did not correlate with a tip and such. So let's implement a simple linear regression model using scikit-learn, a popular ML library in Python. So import libraries. Okay. So we have NumPy as NP, Matplotlib as PLT. So this is like for plotting. We normally do this for like, I think I even have it here. Yeah. So this uses Matplotlib to, the line that has a like slope, it's slowing going downwards. This means like it's getting much better as the model goes on. You can see at the start, it goes down really rapidly. Then over the as it keeps going, it still goes down, which is good. So we want to see a curve. We want to see the loss getting much less. I think it's loss. I can't be 100% though. We'll learn this though. Scale linear model, so for linear regression metrics. These are the loss functions, so mean squared error and R2 score. R2 score was also covered in the Google ML one, but I can't exactly remember what. Oh wait, no, that was L2. I'm sorry. So generate and visualize data. We'll create a simple data set where y depends linearly on x. Okay. So np.rand seed. Okay, so we're seeding NumPy's random generator. So x equals, so we have random, and this correlates to x linearly, according to chatgpt. So we're plotting this, dot scatter xy, title. I will now just get the project up ready. Don't know why there's a breakpoint there. So I've kind of forgotten how to add packages. File. Navigate code, refactor, run, tools. What's this? How did I do it? External libraries. Because in the Python series settings, there we go. And if we have, where is it? Plugins, languages and frameworks, root execution deployment, project. Where is packages? Tools. Python interpreter. Okay, here we go. Install. So we need matplotlib. Matplotlib. I assume this is right. Install package. We need skikit. How do you spell skikit? Skikit. Let me check. sklearn. Deprecated, use skikit. No. It's deprecated this package, so SCI. If I can read this, skikit learn install package and NumPy, of course. Wait, I think NumPy is built in. I'm pretty sure it's built in. I'll check in there. Let's see. NumPy. Okay. Have we got any of these? Let me just retype them in, see. No way it stopped all of them. Oh. Okay, we might have to come back tomorrow to... I'll have downloaded them by tomorrow, or till the next video. I'll just go through the tutorial for now. Actually, why am I doing this? What I'll do is I'll just do it on here, as that's what worked before. New notebook. Wait, I just okay, welcome to Colab. Okay, start coding. That. Okay, let's go. So, first of all, I'll copy this. Takes a while to import these libraries, as you got to install them every time like the page refreshes. I think. I don't think it's stored in the cloud. So okay, so this is just generating the dataset. Okay. So yeah, you can see it correlates linearly with. So we're just generating. We're just doubling. Why is it 100 to 1? Round 100 to. Okay, I'll leave it as is because it's not that important how we generate it here. It's just important that we can just perform linear regression on this. So we're making a scatter graph with X and Y. So the X label is X and the Y label is Y. So title generated data, and we show that. Okay, pretty simple for now. So this is the bit that, this was actually probably the hardest bit. You got to train it in, make it into X train, X test, Y train, Y test. So train, test split, X, Y, test size. Okay, so then I guess it infers that the training size is 80%, 0.8. Okay, so I'm just going to paste it in here. and I'll read the whatever explanation ChatGPT has. So 3 we split into training and testing data sets. So here we simply just say model equals linear regression. This is the linear regression model, I think, from scikit-learn. Yeah, linear model. So then we need to fit it to the X train and the Y train. So Y X equals around. Oh, so this is just the range of the So we have an array. Then 4 plus. Okay. Then regression. And I think this is pretty universal, like how we train this. So it will be easy to like copy and paste this through, because all we're doing is we're splitting our data set into X train, Y train, and then we're just fitting it. And then after this, I'm pretty sure it's model. Just you call one function, then yeah, Y prediction equals model.predict. So this is training a linear regression model, it says, and this is making predictions. If I can now add code. Okay, so now our model should be trained on this training dataset. Now it says evaluate the model, so mean squared error. This is like the is it delta? No, delta's how much it's like how far it is, like in the y axis from the line of linear regression. So mean squared error, and so we have R2 score. Hopefully it will R squared. Hopefully it will explain this. So where are we getting these functions again? Okay, we're getting them from metrics. Still from sklearn. So now I'm just going to paste this in here. So we can see, I think, yeah, the higher the number, the better the model is. So we can see we're having a better score from mean squared error than we are from R squared error. So now we're going to visualize these results. So we're doing a scatter, X test, Y test, and plot X test, Y prediction. Oh, okay. So where are we getting Y predict? Oh, okay. Dot predict. So the testing data set is like, this was the 0.2 bit that we passed into when we split our data set up. So we have 20% is for the test. So we have like 20% of all the data that was there, and we have that on the x-axis. Then our model that was trained on the previously training data gets all the y predictions, and we're plotting them on the y-axis. So it will hopefully create like the same linear and the same with the same gradient as it did with the other one. So actual scatter plot color equals red. So what's the difference between these? X test. Oh, this is Y test. Ah, okay. Color. So this one's what we actually want. This is what it should be, and this is what we actually predicted. Okay. It's not actually explaining the code examples very well. Like, it hasn't explained what R squared is, and I still don't know what. I'm going to leave this as a comment. What is plt.legend? Okay. Now let's see. So predicted. Oh. So this is just. This is just a line. Oh! Okay. Yeah. So it looks like we still got that. You can see we've only got 20% compared to what we had before, which is 80%. We've got a lot more data here. Whereas, so if we go back to the function where we called to split it up, it will probably degrade the how good the model is, but it will show like more data points here. So you can see that is a good linear align, and yeah, we have completed the task of linear regression on this data set. I'll just revert it back. Okay. So the predicted looks just to be a line. Okay then. So that's it for that. So let's move on to the assignments. Objective: implement a simple linear regression model using scikit-learn and a small dataset. Instructions: use NumPy to create a dataset. Okay. Oops. So now, so we've already installed NumPy there. Oops, wrong one. So NumPy to create a dataset where y is a linear function of x. So I'll just copy this bit and so we're seeding that, and I'll have to just change the variable name in a minute. Next thing is got a. I'll just have to put like A for assignment under each of them. So we'll change this up a bit. So we'll do 5 and we'll do 1 and 7. This should give a different look to the dataset, like different look of. Or we can just do -5. So we'll have the gradients being negative. So we'll just run this, make sure it works. Okay, so we've seeded that data set. So we have the X and the Y. And we have the same amount as, oh, okay. Yeah. Okay. Just have a random between that for 100. Okay, now the next bit is to split the dataset. So we can refer to back up here where we split the dataset. Oops. Oh, we can add. No, I won't do that for now. Sometimes, like, I've used it in Replit, and it can be a bit annoying. Like, when you want to do it yourself, you're trying to, like, test it out. Then AI just. But I'm not saying it's a bad thing. I do like AI, and I think it can be viable in the future, especially as these models get more and more advanced. So we can see, no, actually the test size, I mean, it doesn't, like, all it is we're just seeing, like, the more percentage of the data that we see in the end final result is the better it will look. So it's the better we can distinguish whether it's a good model or not. So I think I'll leave it at 2 because ChatGPT chose 0.2 because that's a very good, like, that's the standard for like how much you have, how much percent of the data set you have for the testing. Okay, so now we model training. So train a linear regression model. So I'm pretty sure this was, I'm going to do MSK equals linear regression. So then we're going to do m_a dot fit, and we pass in xtrain, and y train. We need the underscore a. Just checking that everything here as a. I don't think we need any more. No, we don't. So after we've done this, we can do m underscore a dot, what was it? Dot predict x underscore test a. We'll run this first, make sure there's no errors. So the y prediction a will just be this. So now what we want to do is we want to, well, first of all, I want to see this. I suppose I could add some code here. So it was plt dot scatter xa y a. Let me just see the syntax. I'll just copy this for now. No, I won't know this one. Where was okay, plt.scatter. So we can see this looks like this. Oh no, I think because it's supposed to have a negative gradient. And it's supposed to be here. So it'd be x underscore a and y underscore a. So if I run this now, yeah, so we can see we have a negative gradient and we have a lot less deviation between. Okay, so now what we need to do is we need to see the different scores between the different functions. So we can do MSE a score equals mean squared error. Does it tell us? No. So parameters: y true, an array of shape. So is this the y prediction a? Then the second one is let me see. I'll just copy this. Mean squared error. Oh, the difference. No. Oh, y true. That's why. That's why. Nope, I don't know. R2 underscore A MSE underscore A score Y test A right prediction is it right? What's that mean? Y test. I'm not sure what's wrong with this. And then I just copy the code for the plotting. Actually, no, I don't want it here. Okay, so we can see, yeah, mean squared error is also on top, but the R squared score is still very good. Like, there's very little difference between them. So I'm just going to change this for R values. Put my prediction, and I'll run this. And as you can see, the line is very optimal to this dataset. So, visualize. Okay, Trans, can you modify the dataset to include multiple features? X1, X2. Okay, but how do we plot the Okay, I'll leave this challenge for today. I'll ask it for tomorrow's lesson. This concludes day 1 lesson. Feel free to reach out with any questions or further clarification. Okay, so that concludes today's lesson. So I'll thank you for watching, and I'll see you in the next video. Goodbye.